So this is a problem from MASA, as you can see, problem 285. And what we're going to do is first we try to deal with the diagram with information given. So this is a enlarged zoom in version of the diagram with the question part A, and you're being asked to prove this. So clearly this is, seems very familiar, these two parts of the expressions, and it's very usual that a good strategy to think about the Q, and one would suspect that if I add this one later, the extra segment connecting Q to the axis, and when there's right angle, so immediately you see what's going on now. And suppose we name this point A, and you kind of able to see that you could prove this particular identity or this particular equations. Let's try that. So the triangle OQA immediately allow you to see that cosine data is OA over OQ, and OQ is given as cert 5. So there you have it, the OA, which is the first part of the expression. Now let's try and tackle this part, the triangle APQ. And by Pythagoras, AP of square is the hypotenuse square, subtract the length of the opposite, and it also is QA square, or QA rather. So QA, its length could be obtained by using the triangle OQA. So let's try and do that. And the OQ, the QA is this OQ sine theta by using the right angle triangle OAQ or OQA, whichever you like it. And so you have 5 sine square, because OQ is cert 5. So that means the AP is square root. We take only the positive, 8 minus 5 sine square theta. And because what we want to show is the coordinates of P, and so the x coordinates of course is OA plus AP, and you will get what is required. So this is shown. So here I copy this, what we did, what got obtained from part A here, and I'm going to derive it right now. So before we begin the deriving the function, and you notice that this is a square root of this, and I understand that square root also means the power of half. So by using this formula, and just treat n in this case as half, you should obtain the following derivative. So if you perform a careful derivative of this function, you obtain this, and because we want to really get to this expressions, so what we're going to do is we're going to multiply or times both sides by this expression. This is actually 1 over square root of 8 minus 5 sine square, and the outcome will be something like this. So now the challenge is really that we want to see dx d theta, x minus root 5 cos theta, and we are very close because we know what x is. It's really this thing, root 5 cosine theta, and this root of 8 5 sine square theta. And we're very close. We're getting dx theta, this thing, and if we want to see dx d theta times x, we will want to see something like dx d theta with this, and also this particular term. So what we're going to do is, let us create or add something to this into the left hand side, so that this will happen. We want to see this, so we're going to force this into the expression. So what we're going to do is we're going to add. So let's start this one. Please copy this again. So it's going to be 8 minus 5 sine square theta, but because we want to see the dx theta of x, remember our goal, we want to see this, so we don't so we just force this into the thing by adding a dx theta, and what is lacking to form the x is the root 5 cosine theta, and so we're going to do this root 5 cosine theta. Of course we know we can't do this because this is not balanced, so we have to subtract dx theta root 5 of cos theta. And let's just focus on the right hand side now. This right hand side, when I talk about this, I'm talking about this side, and not on the left hand side really, and not the right hand side. So let's focus on this. If we could settle the left hand side, we will know also how to deal with the right hand side. And so let's look at this. So by collecting all this now, we surely dx theta is a common factor, and you can see that I arranged it to look like this. So immediately, once this is done, immediately you see that what this is, right? This really is x, and you have this. So this is used. This is also used. The remaining part the term is root 5 cosine theta, and now immediately you see that this is dx theta x minus root 5 cosine theta, and I'll urge you to do the same with the right hand side, and so that you will somehow get something like this, root 5x times sine theta.